column, like this. I'll say first row against first column. 3 times 4, that gives me 12. Plus minus 1 times minus 5, that gives me 5. That's my first element. I move to the next one. And now we are still dealing on for what? We are still on row 1. 3 times 6, that gives me 18. Plus minus 1 times 3, that gives me minus 3. Now we are through with the first row since we have reached the last column there. Now we are going to the second row. So we'll make use of the second row. 2, 5. 2 times 4 gives us 8 plus 4 times minus 5 gives us minus 25. Second column, again second row. 2 times 6, 12, and 5 times 3, remember the plus, 15. Now the last row, 0 times 4, it's 0, plus 1 times minus 5 gives us minus 5. Next, this row against this, 0 times 6, it's 0, 1 times 3, we have 3. So that's it. You can now finalize. And we have 12 plus 5 is 17. 8 minus 3 is 15. 8 minus 25 will give us minus 17. 12 plus 15 will give us 27. 0 minus 5 gives us minus 5. And 0 plus 3 gives us 3. And what do we have here? We have a 3 by 2 matrix. This is the product of P and Q in this order of P first and Q next. Remember that PQ is not necessarily equal to what? QP. That's it for the first one. We look at PR. PR. That's our P. This is our R. PR. Is it possible? Let's see. P is a 3 by 2 matrix. R is what? That's our R. R is what? A 1 by 3 matrix. Let's take out the comma. A 1 by 3. 1 row, 3 columns. 1 by 3. Obviously, looking at this, we know this is not possible. So we forget about number 2, because the number of columns in P is not equal to the number of rows in R. So P by R is not possible. Let's look at QP. QP. That be possible. Q is a 2 by 2. P is what? 3 by 2. Again, this is not possible. Why? The number of columns in Q is not equal to the number of rows in P. We have 2 here, we have 3 that way. So that is not possible. What about the fourth one, RS? RS, is it possible? Let's see. R is what? Again, our R is 1 by 3. A 1 by 3 matrix. How about S? Let's take a look at S. S is a column matrix with 3 rows, 1 column. That will be 3 by 1. Of course, this is possible. You can see the number of columns here is equal to the number of rows we have that way. So RS is possible. Let's also include RP. But first and foremost, let us treat RS. RS is possible. That's number 4. RS will be equal to, our R is a row matrix, minus 1, 2, 5. And we have here S, it's 0, minus 5, 7. Remember, we take the row and go against the column. So we have row 1, against column 1. Minus 1 times 0, that gives us 0. 2 times minus 5, we have a plus there, that's minus 10, plus 5 times 7, that's 35. There is no other column and there is no other row. So that's all for this. So we have here 0 minus 10, that's minus 10, plus 35, and that gives us 25. What kind of a matrix is this? Only one element. This is a 1 by 1 matrix. One row, one column. And let's look at the pattern of the results. In the first one, PQ, we had a 3 by 2 matrix multiplying a 2 by 2 matrix. And the result was a 3 by 2 matrix. So we cancel this and this. Let's see. For RS here, we had a 1 by 3 matrix multiplying a 3 by 1 matrix, 3 rows, 1 column. And if you rule this out, we have a 1 by 1 matrix. So generally, it therefore implies that if I have m by n matrix multiplying n by, let's say, q, that is equating number of columns, number of rows, the result will be m by q matrix. We'll look at that when we treat RP and see if the result will be in that form. Our R here is what? A 1 by 3 matrix. 1 by 3. And our P is what? A 3 by 2 matrix. Of course, the multiplication will be possible. Let's see if the result will be a 1 by what? 2 matrix. Lastly, we look at RP. Our R is minus 1, 2, 5. And P, a 3 by 2 matrix, 3, minus 1, 2, 5, 0, 1. Here we have a 1 by 3 matrix, 1 row, 3 columns, multiplying a 3 by 2. Of course, you can see we have 3 columns here and 3 rows there. So it is possible to carry out the multiplication RP. Let's go. Row 1 against column 1. Minus 1 times 3. Minus 3 plus 2 times 2. 4 plus 5 times 0. That's 0. That's it for that. Next, we go to the second column. Minus, first this row again against this column. Minus 1 times minus 1 is plus 1, plus 2 times 5 is 10, and 5 times 1 is 5. And then we close. Of course, we don't have a second row, so that's all we have. And the result therefore will be what? Minus 3 plus 4 is 1. 1 plus 0 is 1. 1 plus 10 is 11 plus 5, 16. So we have a 1 by 2 what? Matrix. So the result is correct as was expected, because this is what? A 1 by 3 matrix. And here we have a 3 by 2 matrix. And we said this goes off and our result will be 1 by 2. That's exactly what we have here. A 1 row by 2 column matrix. That's it for multiplication. Next, we move straight and look at the transpose of a matrix. By transpose of a matrix, say matrix P, what do we mean to transpose the matrix? Let's say I have a matrix P, and this is P11, P12, P13, P21, P22, P23, P31, P32, and then P33. And I want to transpose this matrix. The transpose of matrix P, indicated that way, refers to a matrix where the rows of matrix P will now become the column. Or we say that the column of matrix P will now become the rows. So I'll turn row 1 to column 1. So this will now become P11, P12, P13. I take row 2 and turn it to column 2. So we have P21, P22, P23. And I take these and turn it the other way around. And I have P31, P32, and P33. So this is what the transpose of matrix P. Now let's look at another one. This time around, let's take a matrix that's not a square matrix, matrix Q. Let's say it's a 2 by 3 matrix, for example. 2 rows, 3 columns. I have here Q11, Q12, Q13, and then Q21, Q22, Q23. Let's transpose matrix Q. Matrix Q will become, as transpose, will be row 1 becomes column 1. We now have Q11, Q12, and then lastly Q13. And what do we have here? Row 2 becomes column 2, Q21, Q22, and Q23. Of course, you can also view this as column 1 becoming row 1. This is Q11, Q21 becoming row 1. Column 2 becoming row 2. Column 3 becoming row 3. Now, if you look at this carefully, Q is what? It's a 2 by 3 matrix. When you take the transpose of Q, it becomes a 3 by 2 matrix. What do I mean? An M by N matrix, when transposed, becomes an N by M matrix. Let's take an example. I have matrix A. Matrix A is a 3 by 2 matrix. Minus 3, 0, 4, 2, 1, and 5. The transpose of this matrix A transpose will be minus 3, 0, row 1 becoming column 1, row 2 becomes column 2, 4, 2, row 3 becomes column 3, 1, 5. And that's it for what? The transpose of matrix A. Let's look at transposing a column matrix. For example, I have matrix, let's say S. And matrix S is a column matrix. This is 2, 7, 11. What's the transpose of this matrix? Transpose, the column 1 becomes row 1. So I have 2, 7, 11. What do we have here? This was initially a 3 by 1 matrix. 3 rows, 1 column. 1 column there. And what do we have at the end of the day? We now have a 1 by 3 matrix. So we transpose a 3 by 1 matrix, we obtain what? A 1 by 3 matrix. There's nothing more than that for transpose of a matrix. We move straight into determinants of a square matrix. Next, we look at the determinant of the square matrix. What is a square matrix? We said that a square matrix is one that has equal number of rows as there are columns. For example, a 2 by 2 matrix or a 3 by 3 matrix, a 4 by 4 matrix, and so on and so forth. How do we find the determinant of a square matrix? We'll be looking at determinants for 2 by 2 and 3 by 3. First, 2 by 2. Here I have matrix A 2 by 2 matrix, A11, A12, A21, A22. To find the determinants of A, determinants of A is written symbolically with 2 parallel bars there, A. And that means I can also write this that way, A11, A12, A21, A22. This refers to what? The determinant of matrix A. How do we evaluate A11, A12, A21, A22? Determinant will be, we go from top down, A11 times A22. Take note, I'm going this way first, that way first. A11 times A22, A11 times A22, minus A21 times A12, A21 times A12. And that gives us the determinant of the matrix A, 2 by 2 matrix. Remember determinants, what do? Take this off and you have 2 straight parallel bars there, and then go left from top down, A11, A1, A22, minus A21, A12. Let's quickly take an example. I have matrix P. Given the matrix P as 3 minus 5, 2, let's say this is 7. Find the determinant, or let's say find determinant P. P implies we have 3 minus 5, 2, 7. The determinant there is what? 3 times 7. That way first, 3 times 7, 21, minus 2 times minus 5, that's minus 10. Let's take note, 3 times 7, 21, put down the minus, and then 2 times minus 5, that gives us minus 10. And we have there 21 plus 10. The determinant is what? The determinant is 31. I'll take another example. Given a matrix, what do we use now? B, still a 2 by 2 matrix. Let's have here 5, 11, 0, minus 3. Find what? Let's find the determinant of B. By determinant of B, it means we should look for this. And that will be equal to 5, 11, 0, minus 3. I go this way first. 5 times minus 3, minus 15. Minus 0 times 11, that's 0. And the result is what? Minus 15. So that's it. Determinant of matrix P, determinant of what? Matrix B. Go from there, top down, 3 times 7, 21, minus 2 times minus 5, minus 10, and that gives us 31. Similarly, we have for B. Next, we look at 2 questions that are extracts from UTME past questions 2010 and 2011. UTME 2010, paper type B, question number 25. If the determinant of x3, 2, 7 is equal to 15, find the value of x. It's a very straightforward one. We have that the determinant of what? X 3, 2, 7 is equal to 15. We should find the value of x. The determinant means what? X times 7, that's 7x, minus 2 times 3, 6, equal to 15. Find x. So we have 7x equal to 15 plus 6. And that gives us what? 21. So our x is what? 21 divided by 7, and that is what? 3. That's it. Finally, for our 2 by 2 matrix determinant, we take UTME 2011, paper type B, question number 25, right on the board. We are told here if 2353x is equal to what? The determinant of 4132x. We should find the value of x. Now, right from here, the determinant of this is what? 2 times 3x. That gives us 6x minus, please don't forget this, 5 times 3, that's 15, equal to 4 times 2x, that's the determinant on the right hand side, 8x minus 3 times 1, that's 3. So we solve for our x. How do we do that? Transfer 8x this way, we have 6x minus 8x equals minus 3. Transfer minus 15, it becomes plus 15. And here we have minus 2x equals minus 3 plus 15, we have 12. So our x is what? 12 divided by minus 2. That gives us minus 6. So that's it for determinants of 2 by 2 matrix. We run straight into what? The determinants of 3 by 3 matrix. Next, we look at the determinant of a 3 by 3 matrix. Let's take matrix A, a 3 by 3 matrix. This will be A11, first element A12, 1, 3. A root 2, column 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. That's a 3 by 3 matrix. We want to find the determinant of this matrix. Of course, the determinant of matrix A means this. So we'll write this as A11, A12, A13, A21, A22, A23, A31, A32, A33. Straight line there. Now before we can find the determinant of this matrix, first we look at the sign positions. For row 1 we have plus, minus, plus. Row 2 minus, plus, minus. And row 3 we have plus, minus, plus. In obtaining the determinant of a 3 by 3 matrix, we're going to choose one row or one column. Is that we take row 1, or we take row 2, or we take row 3? Or I take column 1, column 2, column 3. Whatever one I choose, I'll be guided by the signs of the positions. Now, so let's take row 1. If I'm using row 1, then I'll plot. I'll be making use of what? Plus, minus, plus. Now watch the way I'm going to do this. I take row 1, the first element there is A11. And I have this. I'm going to include here the minus of A11. How do I obtain the minus of this? I rule out the row containing element A11 and also rule out the column containing element A11. That leaves out A22, A23, A32, A33, and I deposit them there. A22, that's the first one. Let's increase the space.